So before we dive into the rest of the presentation, I thought I would do a little thought experiment with you to give you a feel for what engineering is, the type of real-world problems you can solve as an engineer, and the general mindset and approach to take when solving these problems. So to set the stage, the year is 2028. After being thoroughly inspired by yours truly's presentation, you've all decided to continue and pursue engineering as a career. You've graduated from university, and you've started working at your very own engineering firm, SLED. Now, SLED, what they do is they're a company that manufactures, designs, and builds bobsled, luge, and skeleton tracks. A very cool and niche market, and all your classmates were super jealous that you landed this job. Also, another exciting thing happened in Canada is that Montreal won the 2038 Winter Olympics, and your company got the contract to design and build the bobsled and luge track for the Winter Olympics. And your specific engineering team's task is to design the end section of the luge track. So that's after the finish line and helping the lugers come to a complete stop. So a little fun facts about luge that might help you with your problem. First, it's the most dangerous sport in the world. Fun. Second, the track usually goes down a mountainside. Can anyone tell me why they think we build tracks down the mountainside versus just on a flat surface?
So it can go down?
You can use the force from gravity.
Yes, yeah, exactly. We build them just like how we build ski hills and we pick up a toboggan and go up the hill, is so we can use the force of gravity to build up our speed. And so that's already thinking in an engineering perspective of looking around the world and seeing what physical laws and scientific principles we can use and utilize in our designs. And because we're going down these mountains, lugers can reach up to 140 kilometers an hour, so very high speeds, and they can usually have the average force of 3 Gs on them over the course of the race. So that's the force of gravity 3 times. And so they have very high forces on them and very high speeds, and that's why it's very important when they get to the end section that they're able to stop, not suddenly, but in a nice gradual manner, and not by hitting the concrete barrier at the end of the track, which there's actually some luge tracks in the world where the end of the track is not designed properly, and the athletes really have to dig their toes in to stop themselves before they hit the concrete barrier. So this is actually really important. So to begin our engineering approach, the first step is we need to define our problem. What exactly are we trying to solve? So for our specific problem, what are we trying to solve?
How to stop the bobsled?
Yes, exactly. So we're trying to design this end section of the track so that the bobsled or the luge can come to a controlled stop safely. So now that we have a problem statement, we have to look at our constraints, because before we start designing a problem, we need to know the limitations of our solution. So what would be some limitations or things we need to consider when we're designing our solution for the end section of the track?
The finance that goes to?
The finance? Yeah, exactly. So money is always a constraint in engineering. We have all these fancy ideas, but someone in business comes to us and is like, no, you can't spend $1 billion designing a luge track. Do we have any other ones?
Maybe the space you have available?
Yeah, the space. We can't just have the track shoot off of the mountain for a kilometer while they slow at their own speed. Do we have any other ones? A couple other ones could be the fact that we have luge as well as bobsled. So we have a variety of athletes at different weights, and we have a variety of sleds at different weights, and so we have to be able to have a reliable method that can stop a bobsled in a specific amount of space as well as a luge. And then also something that could be reliable over multiple runs, right? Because we can't have something that we have to run and go set up every run. And so now that we have those design constraints, as well as the general problem, I want everyone in pairs to maybe brainstorm for a couple minutes and come up with 2 features that they think they could add to the end section of the track that would slow down their sliders. Okay, so it sounds like everyone has kind of come up with a few really good ideas. So what are some of the solutions we've come up with? Yes.
So decrease the force of gravity.
So to decrease the force of gravity. So how would we do that?
You would flatten the surface as the sled would come to stop, and then you can
You can incline the track?
Yes.
Yeah, exactly.
Yes.
Yeah, so you can flatten the track after the finish line so that we no longer have gravity working to increase the speed of the luge. And we can also even turn the track so it goes back up the mountain slide so that the force of gravity is counteracting the speed of the luge. That's a really good one. That's actually what they do in real life. You'll see, if you look at luge tracks and bobsled tracks, you'll see that they actually loop around and go back up the mountain after the finish line. Can we think of another feature we could do? Maybe over here.
Kind of making the track at the end more rough or having more friction so that we can slow down the luge.
Yeah, that's another good one. We know that friction slows us down. A lot of times we actually are trying to decrease friction so we can speed up, but in this case, since we're trying to slow down, it would be benefit to increase the friction, and just as you said, we can do that by increasing bumps or certain features in the ice after the finish line. So those are both really good options. And so if we were actually in an engineering design company, what would be our next steps once we've come up with this solution, or this potential solution?
Research material, ways of increasing the friction, and how is the best way to make the path go upwards instead of downwards.
Yeah.
Calculations and make some models to try to kind of predict.
Yeah, so the next step would be to actually research how we would do these solutions and then build a prototype and test it. And that's kind of the whole engineering approach to solving a problem. And if you're interested in engineering and you continue it, at the University of Calgary, there's lots of options for you to take courses where you actually go through this whole design cycle. And if you take the Summer Bioengineering Institute, which I will talk about later, you can actually specifically work on this problem where you'll get to design your own luge track and the end section of your track and test out your theories. So hopefully this kind of gave you an idea about the type of problems that you can solve if you continue engineering, as well as the general mindset for the engineering approach to solving problems. So now that you kind of have an idea of what engineering is, now I can talk about what I think engineering is and why I love it so much.